Today I have this old Jeep, it's a 96, and complaint to this car is that the battery will go dead after a couple of days if it's sitting outside and if it's not driven. Now the battery was completely dead, and we got new one. Actually, the battery was purchased last year and I just warranted back in October, so like 10 months ago, and so I got the brand new battery in it. The charging system is working fine now. We have all these cables are kind of frayed, so I got that fixed up. We have excessive voltage drop on the ground wire. This one here, kind of the post is here somewhere, so I got that cleaned up. Then now the charging voltage is 13.5 volts. It was around like 12.8, and after I fixed that, then we still have an issue where we have excessive drain, parasitic battery drain. So right now I have my adapter plugged in. Switch is closed. This is actually one that you can buy like AutoZone. The one thing that I have added to it is these two leads here. I soldered it, so this allows me to use my Vantage Pro. I like to use a internal graphene ammeter. It's to me more precise than using an amp clamp. You can use amp clamp as well, but I like to use internal ammeter, and I can record long period of time. It gives me very precise amperage measurement. So right now what I did, actually, this is an old car, so the door switch is there, so I've got that pushed in so that internal lights are off. And so the next thing what we're gonna do, we're gonna set our tool. We're gonna turn this unit on. Now this internal ammeter, pretty much like you know, this unit has it. The nice thing about this one, it gives you a graphing mode, and you can record long period of time. Now it's of course it's a 10 amp circuit. It's protected by this fuse in the back. It's an expensive automotive fuse, and that's why I like this the best. Of course, we can use, as I said, we can use amp clamp, but I just like to use this unit. Now, in order to hook it up, we're going to use these two leads now. The one goes to the ground, and one will go to this blue channel here. Now, as far as I know, this is the only Snap-on unit that has this option, internal ammeter. The older Vantage that has it as well. The problem with the older one, it's the battery powered, and you know, if you want to leave it overnight, it's not going to work because the battery is going to go dead. Now with this one, I can plug in my AC adapter, leave it overnight, and record what I need to do. And also you can actually use a 2-channel. You can use an internal ammeter, and as well as a yellow channel, which is here. You can actually record a voltage as well, so that's a very nice option as well. So right now I'm gonna hook up this other lead to this blue channel here, and next step we're gonna be to set our tool. We're gonna go down to a graphic multimeter. We're gonna press yes, and it gives us the menu. Right in here we have an amp internal. Now we got also option to use a low amp meter with a amp clamp, 20 or 40 amp mode. So now I'm going to go to this internal, press yes, okay, and I'm going to go down to, now here you can set your amperage. You can go up to 10 amps. Go 10 amp. I'm going to go down to half an amp, 0.5. Now, as I said, if you want to check, if you want to do your voltage, you can go here, press yes, and it's going to give you an option to activate channel 2, and that's going to be your green channel. I'm not going to use it, but you have that option as well. And if you want to check the voltage, now in order to do that, you will have to splice the ground side, because you're going to use the ground for voltage as well. So you're going to use the yellow channel and the ground. So you're just going to shave the ground between internal ammeter and a voltmeter. I'm going to now turn the channel 2 off, and I'm just going to use an internal meter. Okay, at this point my meter is ready to do a measurement, and the next step I'm going to do now, at this point, you know, the current is going through this big switch here. The little bit of current, as now it's kind of in a parallel, so some of the current is going through the meter already, but when we flip the switch on, everything that's in that's draining, everything that's gonna stay on in the car, all of the current is actually going through my internal amp meter. Now why having this unit here on the modern cars, it takes a while to put car to sleep. It's not a good option to use this adapter anyway. It would be the best to just use a amp clamp, but like here you have a clamp, you got two negative cables, you cannot put one clamp over. So I know this is not a best option in modern cars. Sometimes you have to relearn your throttle body, but this is still the option that I'm using. Next step will be, as I said, once I turn this, once I flip the switch off, all the current will go through the meter now. And there was something else I was going to say, but I forgot. So anyhow, this is what we're going to do now. We're going to turn the switch off, and we're going to look at the amperage, and we can see we are going immediately to 270 milliamps. So we have a draw. Now, the next step is to figure out, you know, do we have a constant draw or is intermittent? I was watching one of the method that I'm going to use now. So the next step is to find a circuit that's give us this draw, and there's a couple different ways now. We can start pulling the fuses and see if the amperage drops, or we can use a voltmeter and in a millivolt mode, and look at the voltage drop across the fuses. Now I was watching one of the videos and from one of the YouTubers where was bashing this method, and they said it was completely useless, and I disagree, because his problem was actually intermittent. He was saying that pulling the fuse is best option. Now with the intermittent issue, you are hosed anyway, because whether you're pulling the fuses or looking at the voltage drop across the fuse, if you don't have a draw, you don't have a draw. Now in that case, most likely what you will have to go is to I mean, that's very difficult, there's no question about it. Then, you know, using maybe a thermal imaging cameras or whatever, but this method does work. So right now we are lucky because we can see we have a constant draw of 270 milliamps. This is way over. This will kill the battery, especially like in 20 or probably 48 hours. You know, the brand new battery will be dead, and you're not going to have enough amperage to crank the engine. So our next step will be to use a voltmeter, and we're going to go from we're going to check some of these fuses here. There's another fuse box inside the car. Now this method, of course, is a little bit difficult on the different fuses. It has like the glass cover. You have to pop the cover off and check the voltage drop. Now there's a chart that will tell you how much amperage draw is on that circuit, depending of a amperage, depending of the type of a fuse you have, depends of the amperage of the fuse, and also of the voltage drop across the fuse. I generally don't look at that. I really don't care. As soon as I see the voltage drop across the fuse, that circuit is alive, and that's going to give me a direction to see, you know, I'll go from there. Alright, so we're going to use our voltmeter. We will turn it to the millivolt scale and use our leads, and we're gonna put each lead across the fuse, and it's supposed to be a clear 0. If you have 1 millivolt of current, of voltage drop, I'm sorry, there will be that circuit is alive. Now you're not gonna have a huge voltage drop. This is just a small voltage drop across the fuse, but there will be a voltage drop. So if you have a current flow, you're going to have a voltage drop across the fuse. So let's start checking the fuses. I do remember now what I was going to say. So the question is, why do I have this adapter here? The reason is that on the modern cars, in order to lock the car, you have to, to press your remote control, and at the time the car is not completely asleep, there will be a significant voltage, amperage draw, and when you press the lock key, the headlight's gonna it's gonna pop, the horn's gonna honk, and all that. So there will be possibly amperage draw over 10 amps, and so having a meter hooked up in series, it might just keep blowing your fuse. You're never gonna completely put the car to sleep. So that's why I want to have this adapter. I can have this switch all in my closed position, leave the car for a certain amount of time, and then I can actually use my amp clamp and then check the amperage draw on each of these cables, and once I'm below 10 amps, then I can open the switch and then have my meter in series. The good thing also is that if you have some kind of intermittent problem and you're recording something overnight, and if for some reason something crazy happens, maybe the cooling fans are turning on, or some excessive draw, they can draw over 10 amps. So these fuses will not handle that. These wires will not handle that. And of course, the good thing is we have an internal fuse. It's going to blow. It's going to close the circuit, and we're going to be safe. So this is another feature that I like about this tool as well. Okay, so the next step, as I said, we're going to put our meter into a millivolt mode, and so now I'm going to see, guys can see that. All right, I think this will be fine. We will go straight from one fuse to another. As I said, we will put our leads across the fuse, but you got to make sure. Sometimes your voltage might fluctuate on your meter. You have to make sure that it's good to have some kind of leads with a very fine tip, and so I'm going to put one here, so across the fuse, good connection, and you can see it has 100% zero. The next one, so as soon as you take your leads apart, you're going to have some kind of reading, okay, on your meter. And so go to next fuse again. See, right now I don't have a good connection on my the leads are not connected to my fuse, so I have to make sure it's okay. There you go, it's 100% zero, and then go here and here, and zero again. So I already checked all these fuses, everything is fine. The next step, we're going to go to a fuses under the car, and you can see still we are constantly having a draw of 260 milliamps, which is actually, again, a lot easier. We will find a circuit that's drawing a current, and of course the other method is just simply start pulling the fuses. That can be a problem sometimes, especially in modern cars. By popping fuses in and out, it can wake up the modules and causing issues where you have to wait again for the car to go to sleep. And I'm going to pull the fuse, and we still have the same amperage draw. And again, that's another method which I do not like for that very reason. Now, if you have an intermittent problem, that's something you might have to do: pull one by one fuse and wait forever for that. See if that draw is gonna go away or not. But again, having an intermittent problem, that is a complete nightmare. Let's go and check the fuses inside the car. Okay, so I'm at the internal fuse box. This is on the passenger side, right beneath the glove box. And let's just go ahead and start checking our fuses. I'm not going to take too long. I'll already diagnose it, so I'll show you. So here, let's just take. You can pretty much go from, start from one fuse. Then I can see we got. I can see that it got zero here. Zero on this one, zero on this one. Okay, and let's check this one here. This is number 16, and I have 1.7 millivolts of a voltage drop. So right now, you can see we have this. Let's do this again, and we have a constant voltage drop of 1.7 millivolts. Now again, you can have a chart and it will tell you how much amperage is drawing, but what we can do actually right now, simply we can pull this fuse out, and of course we can look at the amp meter to see if the if the amperage drop, but we can just switch your leads on your meter, go to a internal amp meter on this meter here, and just get your leads, put them inside the where the fuse is, and you can see we have 248 milliamps of current, and that is my problem. That's where we have an excessive draw. The next step is, first get your leads back. You don't want to keep your leads in the amp mode and check voltage, because you're going to have a jumper wire, you're going to fry something off. So yeah, we're going to check our the amp meter up front, and then we have to look, it's number 16 fuse. We got to go to we got to check the our sorry guys. So next step will be to we can check the meter up front to make sure that amperage had dropped, and this is a number 16 fuse, and we need to look at the wiring diagram, see what this fuse actually is, where this is giving the power to, what components is power this fuse here. And we can see here that our drop, the amperage drop went to 22 milliamps by pulling the fuse number 16. Okay, looking at the wiring diagram. Here's the interior light circuit. It's the fuse number 16. It feeds a underhood lamp, feeds a glove box lamp. We have actually a lot of components here. We have a dome reading lamp. We have a overhead console. What is here is left visor, and so our problem is actually in here. Let's check this. Let's check this glove box. By looking at the glove box, we can see this door is not closing all the way. Let's go ahead and put the fuse back in. And you can see the light is. You can see that light bulb is actually on. So now we need to kind of use some kind of suture or something to keep it together. So what I'm going to do, most likely it's not going to fix this. So what I'm going to do, I'm just going to pull the light bulb out, and that should take care of it. Okay, cut this off. All right. So there's the lamp, there's the light bulb. So I think I can actually pull this out and alright, I'm just going to pull this light bulb. Okay, bulb is out. I'm going to close the door, and we'll see how long it will take for internal lights to go out. So right now our amperage is over half an amp because of internal lights, and I can go here and up to 2 amps. Actually got a 4 amp draw, so let's go ahead and let's go to 10 amps. So all I have to do now, there you go, the lights are out, and we have a 200 milliamps of voltage drop. Still I'm gonna wait a little bit longer to see if this goes away, but we still have a problem. There you go. Now I went to sleep. Okay. Alright, so this was still excessive. There's some kind of module was on, and 37 milliamps, I'm fine with that. Everything below 50 milliamps, it's not a problem. And so now the draw actually went down to 22 milliamps, and I'm going to leave this on for a little bit longer just to make sure that I don't have anything else, going on. But this was not a difficult one, but the process is actually the same for any amperage draw that you might have. Now, before you attack the amperage draw, you want to make sure that the battery is fully charged, that the battery is in a good condition. I had to replace this one. You have to check your charging system, make sure the charging system working fine, which is actually this one was not, due to excessive voltage drop on a ground side of this circuit here. And then the next step is actually figure out, we have to find out, is it an intermittent problem or is it a constant draw. If you have a constant draw, you will find it. You just go from one circuit to another and you will figure it out. Now what you're going to do, you're going to pull the fuses or check the voltage drop. It doesn't really matter. I don't like to pull the fuses because they can actually cause problems by waking some modules up, especially on newer cars. If you have an intermittent problem, well, good luck finding that. Again, I was watching that video and the guy was completely bashing this system, this way of finding the your circuit that causing an issue. Again, if you have an intermittent problem, if it's not there, it's not there. Whether you put in the fuse or checking the voltage drop, if you don't have a current draw from some circuit, you will not have one. So how are you going to find it? It's very difficult. Next would be to check the TSBs to see if there's something common on that make and model that could cause that. Like for instance, like BMW that I have X5s, their very common problem is actually the resistor on the blower motor that gets shorted out, and it would turn the blower motor on and drain the battery. Again, how are you going to find that? Good luck, because it happens, maybe for an hour or something in the middle of the night. Then I don't know. I mean, something else you can use, a thermal imaging camera, see if some of the fuses are hot, or maybe some of the relays and something like that. But other than that, I mean, that's very, 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 very difficult. As a matter of fact, I had a guy that had a what it is, Hummer, and has intermittent draw, and I had a car for 48 hours, checked everything was fine. Also had issues with the cables. I fixed the cables, and then I said I explained what has to happen for me in order for me to start attacking that problem. And again, the battery was fine, the charging system was working well, and everything was fine until like 2 weeks later. He said, I cannot start the car again. And I told him, I said, don't do anything, don't jump the car. I want to see if there are any other issues with the cable, even though I did check the voltage drop on the ground side and the positive side. I said, don't do anything, call me, I'll come to your house, and I want to check to make sure that I want to see the voltage. I want to measure the voltage on the battery. Sure enough, it was 2 volts. Something did drain the battery overnight. We did notice that the door would not close all the way, the driver door. I said maybe that was the cause. And I said just make sure you push the door all the way in and make sure the internal lights are going out. Apparently there's another problem. The common is a problem with one of the modules. I can't remember what it was for. I don't remember, but I told him, I said I can't work on this car. For something that happens once or twice a month, it's pretty much impossible. It's just the way it is. I said I can't waste my time, and I mean you just can't really figure that out. It's very difficult. But this one was constant draw. So anyway, when you're looking for the draw, you have to know. And it's actually easy to figure out. You're gonna put your clamp or ammeter, and if you see if you have a draw or not, and sure enough, if you see one, if you have one, you will find it. If it's intermittent, okay. Anyhow, this is what I do, and I do like this method. I do like this is my go-to tool for amperage draw. And I like this setup here, works very well. And yeah, that's it. Alright guys, thank you. See you next time.